Hey everyone, ready for a deep dive? We're talking all about hydrogen today. And you might be thinking, hydrogen, isn't that kind of basic? And yeah, it's everywhere, right? Like it's in water, it's in stars. But the story of how we figured all that out, well, let's just say it's a bit of a wild ride. We're talking alchemists, exploding gases, even scientific rivalries that honestly could give your favorite reality show a run for its money. So buckle up, because by the end of this deep dive, you'll be seeing hydrogen in a whole new light, I promise.
Oh, go.
All right, so picture this. It's the 1500s. You're an alchemist, basically like the mad scientist of the day, right? You're mixing potions, trying to turn lead into gold, the usual. And one of these guys, Paracelsus, he's messing around with some metals and acids. And boom, suddenly this flammable gas just starts bubbling up.
Really captures the almost accidental nature of these early discoveries, doesn't it?
Oh, absolutely. You can practically imagine him just like scratching his beard, like, what in the world is this? Because back then, they didn't really understand gases the way we do now.
No, not at all. I mean, they knew air existed, obviously, but the idea that there were all these different kinds of airs, each with its own unique properties, that was revolutionary.
It's amazing how something we take for granted now was a huge deal back then.
Absolutely. And what's really interesting about Paracelsus and this flammable gas, this hydrogen, he wasn't even looking for it. He wasn't trying to understand these strange airs. Alchemy back then was much more about mysticism and, well, transmutation.
So they were more focused on actually transforming matter, not really breaking it down and analyzing it like we do now with modern chemistry.
Exactly. Gases were just sort of
Yeah.
there, a mysterious byproduct.
Makes you wonder what we might be overlooking today, right? Like, what invisible things are out there that could totally change our understanding of the universe in the future?
It's a humbling thought, isn't it?
For sure. But getting back to our story, Paracelsus wasn't the only one who noticed these strange, flammable gases. About a century later, there was this guy named Robert Boyle. And if that name sounds familiar, you might be remembering Boyle's law from physics class. Well, this Boyle, he was obsessed with these gases. See, he was all about rigorous experimentation.
A stark contrast to the alchemists, wouldn't you say?
Totally. Boyle wasn't content with just seeing something happen. He wanted to measure it, quantify it, really get to that why behind it. And that's where things start to get really interesting, because Boyle's work, well, it kind of laid the groundwork for everything that came next.
Yeah, his emphasis on measurement and experimentation, that really set the stage for understanding gases as these distinct entities.
And it paved the way for, well, a pretty important character in our story, a guy named Henry Cavendish.
Oh, Cavendish. Now, there was a meticulous scientist.
Seriously, like the ultimate lab rat, meticulously recording every single detail of his experiments.
And it paid off because in the mid-1700s, he ends up, well...
striking gold. Or should we say striking hydrogen?
Exactly. He was working with metals and acids, kind of like Paracelsus.
But Cavendish, he took it to a whole new level of precision.
Oh, absolutely. He reacted metals, specifically zinc, with acids, and in doing so managed to isolate this incredibly light, ridiculously flammable gas.
And he realized this wasn't just some random gas bubbling up like what Paracelsus had seen.
This is something different, something totally new.
Cavendish had officially discovered hydrogen.
And it's funny because you think about discovering something.
It's like finding a new island or a hidden cave. Right?
But this was different. This was discovering something that was everywhere, literally all around us, but just unseen.
And just like discovering a new island can totally change the map of the world, identifying hydrogen as this distinct element, well...
it completely transformed the scientific landscape.
It was a paradigm shift.
Totally. And here's where it gets really interesting.
Because Cavendish didn't actually call it hydrogen.
Nope. In fact, he thought he discovered something even more fundamental.
Even more fundamental than a new element.
He did. You see, at the time, the going theory about burning, about combustion, was all based on something called phlogiston.
Phlogiston. Okay, I'm going to be honest. I'm drawing a blank here.
Yeah. Basically, they believed phlogiston was this invisible, weightless substance, and when things burned, they thought it was phlogiston being released.
So, like, imagine thinking that fire was a physical thing trapped inside objects just waiting to be set free.
Exactly. It seems kind of wild now, but that was the prevailing theory at the time.
And Cavendish, brilliant as he was convinced that this super light, crazy, flammable gas he'd isolated.
He thought it was practically pure phlogiston.
Whoa! He thought he'd bottled the essence of fire itself.
He did. Talk about a scientific cliffhanger.
Yes, totally. So we've got Cavendish, convinced he's cracked the code of combustion. But the story doesn't end there, does it?
Not even close. Because now we introduce Antoine Lavoisier.
Now there's a name that even I recognize. The father of modern chemistry.
Lavoisier took what Cavendish started and added, well, his own signature meticulousness.
And maybe a bit of, dare I say it, a bit of flair. Flair, precision, and a knack for really selling those scientific breakthroughs, right?
Oh, definitely. And Lavoisier knew how to make a splash, even in the world of 18th century chemistry.
So what did Lavoisier do with this so-called phlogiston that Cavendish had discovered?
Well, he starts by doing what Lavoisier did best, repeating Cavendish's experiment, but with even more precision and control. And as he's observing this flammable air burning, he makes a game-changing observation.
What's that?
He realizes that it's not releasing phlogiston at all. It's actually combining with something.
Okay, so what is it combining with then, if not phlogiston?
It was combining with oxygen.
Oxygen. Now that rings a bell. It's everywhere. We kind of need it to, live.
Exactly. And Lavoisier's experiments showed that this new gas, hydrogen, it didn't contain phlogiston. It reacted with oxygen.
And when hydrogen and oxygen get together, they make
water. Just good old H2O.
Wow, that's incredible. So all this time, people thought water was this basic element.
But it turns out it's not an element at all. It's a compound made from two elements.
So Cavendish isolates hydrogen, thinks it's phlogiston, and then Lavoisier comes in and basically blows the whole phlogiston theory out of the water, literally.
It was a mic drop moment in the history of chemistry, no doubt.
It really makes you appreciate how these scientific discoveries, they're not isolated events.
It's like building a puzzle, one experiment, one discovery at a time.
So Lavoisier figures out that water is hydrogen and oxygen, not an element in itself, but what happens next? How does this discovery kind of ripple out and change things?
Well, in many ways, this is where modern chemistry truly begins. I mean, for one, Lavoisier gave inflammable air a brand new name. Hydrogen.
From the Greek words for, what was it again? Water forming?
Exactly. And along with giving hydrogen its name, he pioneered this whole system of chemical nomenclature.
Which, if I remember correctly, is still the basis for how we name chemicals today.
Precisely. And maybe even more importantly, Lavoisier's work revealed this fundamental principle.
What's that?
That elements could combine, but in very specific ratios to create entirely new substances. It's like he cracked the code, uncovered the basic grammar of the universe.
And this breakthrough, it sets the stage for, well, let's just say, a pretty important development in chemistry. The periodic table.
Exactly. Lavoisier's work with hydrogen, it really laid the foundation for organizing the elements in a meaningful way.
So, in a way, we can thank Lavoisier for that giant, sometimes intimidating chart on the wall of every chemistry classroom.
Absolutely. Who knew that figuring out what water was made of would eventually lead to the periodic table?
It's remarkable, isn't it? It just shows how interconnected everything in science really is.
Absolutely. And, it doesn't stop there. Lavoisier's discoveries with hydrogen also played a crucial role in another major scientific breakthrough.
Oh, yeah. What was that?
Well, remember John Dalton and his atomic theory?
Dalton. Atomic theory. Oh, yeah. He's the one who figured out that everything is made of these tiny particles called atoms, right?
Exactly. But Dalton had this problem, figuring out how much atoms actually weighed, their relative masses.
That makes sense. Atoms are so small, how could you possibly weigh them, especially back then?
Exactly. But hydrogen being the lightest element, it became the measuring stick, the baseline.
Interesting. So by understanding hydrogen's properties, Dalton could start to figure out the weights of all the other elements, kind of like using hydrogen as the reference point.
Precisely. Hydrogen wasn't just a building block of the universe at that point, it was also the ruler.
Wow, that's amazing. So hydrogen is literally everywhere. But I've also heard about how hydrogen powers the stars, right?
Exactly. It's all thanks to a process called nuclear fusion. Basically, under the immense pressure and heat found inside stars, hydrogen atoms, they fuse together to form helium.
And that releases huge amounts of energy in the process.
You got it. Think of stars as these gigantic fusion-powered hydrogen reactors.
That's mind-blowing. So hydrogen, this seemingly simple element, it's powering the stars, it's in the water we drink, it even helped us unlock some of the biggest secrets of chemistry. Kind of makes you wonder, what's next for hydrogen? What's the next chapter in this wild ride?
Well, that's the million-dollar question, isn't it? Today, there's a lot of buzz about hydrogen as a potential key to a cleaner energy future.
Oh, yeah. Hydrogen power. Right. I've heard about that. But how does it actually work?
The basic idea is that you can use hydrogen to generate electricity through devices called fuel cells. And the best part? The only byproduct is water.
So imagine a world where our cars, our homes, our cities are all powered by hydrogen, emitting nothing but water vapor.
That's the dream. Clean energy and abundant resource, what more could you ask for?
Sounds almost too good to be true. What's the catch?
Well, as with most things, there are challenges. Producing hydrogen on a large scale still relies heavily on fossil fuels, which, well, kind of defeats the purpose of clean energy, right?
Yeah, that makes sense. And I imagine storing and transporting large amounts of hydrogen safely can't be easy either.
Exactly. Those are the big hurdles right now. Finding ways to make hydrogen production truly sustainable and figuring out how to store and transport it safely and efficiently.
So it's like we're at another turning point with hydrogen. Just like Cavendish and Lavoisier were back in the day, we're trying to crack the code, figure out how to harness hydrogen's full potential.
And who knows, maybe someday we'll look back at this time as another turning point in the story of hydrogen, just like the discoveries of those early pioneers.
From alchemists accidentally creating flammable gas to potentially powering our world, hydrogen has had one incredible journey.
And it all started with a simple question. What is this stuff, anyway?
It makes you wonder, what will be the next big hydrogen breakthrough? What seemingly simple questions today might unlock the scientific revolutions of tomorrow? Well, that's all the time we have for today's deep dive into the explosive history of hydrogen. A huge thank you to you for joining us and sharing your incredible knowledge.
It's always a pleasure to dive into these fascinating stories from the history of science.
And to all our listeners, we hope this episode sparked your curiosity and left you wanting to learn even more. Until next time, keep exploring and keep those questions coming.